So as a group, did you guys get an inflection point somewhere? X equals 2? Can you guys put on a little board what you found? So, okay, so it says find intervals where f of x is concave up and down and list any points of inflection. So, alright, Zach, what do we have to do to find inflection points? What is that?
It's like, what is the derivative is like equal to 0 or undefined?
First derivative?
First or second.
Either? One in
No,
particular?
Second.
Okay, we need to find the second derivative. Alright, here. First derivative, please don't do quotient rule. If you did quotient rule, please look up. Multiply by the power. What is the power on x minus 2? Negative 1. So multiply by the power. Lower the power. So much easier than quotient rule. Please don't do quotient rule if there's just a constant. Okay, so that's my first derivative. Critical points are where it's 0 or undefined. It's undefined at x equals 2. Second derivative. Do I need to do quotient rule or can I be all like fancy with power rule? Fancy with power rule. So Stella, do the derivative with fancy with power rule. Multiply by the power, lower the power. Okay, 4 over x minus 2 to the third, and then chain rule, derivative of the stuff inside is just 1. It is also undivided at x equals 2. And on one of the boards, I saw a number line with a 2 and a minus and a plus. It was not named. Is this first derivative, second derivative? What is that? Second derivative, okay? Because it matters, first derivative, same critical point, and it's a Debbie Downer the whole way. Thank you. So, Evan said the function is concave up from 2 to infinity. Why? Because f double prime is greater than 0. Why is it concave down there? Because f double prime is less than 0. However, x equals 2 is not an inflection point. Definition is the second derivative is 0 or undefined, and the concavity changes sign, but it's not an inflection point. Why? Because the function itself doesn't have a coordinate there. What is the domain of the function? Domain of the function in the first place can't be 2. So you can't tell me the function has this attribute at x equals 2. Like at x equals 2, there is nothing in the function. It's vertical asymptote. So be careful. They like to do this to you. They will lull you in and be like, just pray through the process. Just do the process. Haha, it's not there. Check that the initial conditions are valid. Cool, nifty. Questions? Yeah.
So we check by plugging each inflection point into the original function.
Okay. I would say, like, they don't do this often, but they do this sometimes. What's the domain of your original function really is supposed to be the question that we ask before we start anything. And I forget after a while. So just put it out there that sometimes you might need to back up and say, wait a second, that coordinate's not in the function in the first place. Yep.
Were there to be a point in reflection, we'd have to put it back into F(x) though, right? Or do you only
To find the
take it
y
out?
value,
Right.
if I ask for the actual point of inflection, it would be at 2, comma, But usually they ask just for the x values, so you might not catch it. Other questions? So we finished, I think, all of these yesterday, but just to reiterate, if I tell you something's some function's differentiable, it guarantees a smooth curve. And then if I tell you it's differentiable and always y prime, the first derivative is always positive, it makes this smooth out a lot more. Like, it's gotta forever be going up. It doesn't have to go up straight, but it can't turn around on itself. And if I tell you it's differentiable and always second derivative positive, concave up makes a cup. It could be one half of the smile or the other. So, using what you know from calculus and pre-cal, graph that without a calculator or Chromebook or other technology. Just the brains. And group scribes, or reporters, I wanna see them on the whiteboards. Alex, what are useful things that we should be looking for?
Like coordinates of x plus 1 and minus 2. Or like,
What do you mean coordinates?
Like when those equal 0.
Okay, finding the, what are those?
The zeros.
Finding the x-intercepts, okay? Yep. So that one's like given to you straight up. What other attributes can we figure out? Like, you guys are all working on something. What are you doing? Looking for critical points, because maybe there's a maximum in there. How do we find critical points, Michael?
First derivative.
First derivative, and finding where the first derivative is what, Evie?
Oh, the first derivative of that?
When, like, they said, to find critical points, you do the first derivative, and what do we have to look for in the first derivative?
Oh, when it's 0, when it's undefined.
When it's 0 or undefined, yeah, okay. So Matthias, can you do the first derivative for us on the board? And Evan, can you do the second derivative when he's done? G, are you gonna use the first form of the equation, or, oh, you gotta use the butt of the pen, the point, for whatever reason, doesn't work. Okay, first derivative. And Evan, can you do our second derivative? Okay, Christy, can you tell us, can you come up and find critical points? Okay. Nope, nope, that's great. So she took the first derivative and found where it was undefined, which is never, and then found where it's 0. Are they critical points right there? Are we done checking that they are, in fact, critical points? Yes. Okay. Sebastian, can you show us how to find inflection points?
Wait, so like with the number line of the double derivative, is that what you're asking?
I don't know. I want you to verify that we do or do not have inflection points, which, Julia, what makes an inflection point an inflection point? Don't know? Flynn?
It's like 0 or undefined.
When, what is 0 or undefined?
The point is 0 undefined.
So
Point, not,
would this be the inflection point because the sign is changing from the, like
The
the
sign of what?
concavity of the f double prime
Yes.
function, so the
Yes.
concavity, and then when you plug it back in, it's like defined, so
Okay.
it is an inflection point.
okay, yes, exactly what he said. So what he did, find an inflection point, where is the second derivative 0? He didn't show the word because he's smart like that, or it was that easy. He's like, it's at x equals 1, and then he did the number line, because critical points, just right here, she was done. First derivative was 0 undefined. Inflection points, second derivative 0 undefined, and then he checked the number line that he named, and it changed sign. Yes. Okay, and then he's like, and I looked back here. The function is defined over all real, so it's defined at 1, 2, so it legit, straight up, is an inflection point. Okay? Nobody has this graph drawn on their boards yet. Guys, try drawing the graph with the information we have. Oh, there's one. And Alex, you said what from the beginning? What did we know about this?
That x equals 1, x equals 2 are the zeros.
Okay, from algebra 2 and pre-cal, where the function itself is 0, we know it hits the x-axis. That this is a double root, what do you know?
Goes back up.
It bounces. So it's gonna touch down and go back up. So x equals -1 and x equals 2 are zeros. Do I know the y-intercept?
Yes.
Which is? 4. How do I know that? Put in 0 for x. And I stopped Christy from finishing this. She was like, should I? No, no. So, checking the second, those critical points on it. When X is 1, I get a negative number. When X is negative 8 million and positive 8 million, I get positive numbers. So the function is going up until 0. Up until 0, and it's concave down till 1. Up until 0. And at 1, it's an inflection point. What is the coordinate when we're at 1? 2. So it goes from being concave down to concave up, right there. Top this down, hits a minimum. It's a minimum where? At x equals 2, because it was negative, the first derivative was negative and then it went positive. Kind of, sort of, yeah? Okay, questions? So again, first, fourth, and sixth, between all of you, you guys voted for the quiz on 4.1 to 4.3 to be on Monday. It will be on Delta Math. You will not be allowed to use your graphing calculator, because finding extremes then is just type it in and do code, so it's right there. We will give you the stupid blue calculators, because I can't guarantee what numbers you'll see. So be able to do like 7 times 7 times 7 on the little stupid blue thing. And Friday we will do start optimization, which is applications of 4.1 to 4.3. And you should have gotten an email that the AP student practice in Unit 3, Level 2, is due on Saturday, for whatever stupid reason. Just clicked a random number. And those are gonna drag you through how to solve free response questions. We're gonna do all of the Level 2s through Unit 10. This is your first one, yay! I see the enthusiasm. Ooh, yeah, okay. Okay. Try figuring this one out. Time velocity and acceleration given, moving along the x-axis. Is that up, down, or left, right? Left, right. X-axis is left, right. find velocity.
Derivative of that x t.
What is that?
6t squared minus 28t plus 22.
That's gross. I have any critical points?
Still working on it.
How do we find Roman, how do I find critical points?
Find, t equals 0.
Does it factor? I found the greatest common factor. Does this factor? Lynn says yeah. Ray says yeah. Okay, Ray, how does it factor?
3t minus 11, t minus 1.
You guys just see it? Like, if it's gonna factor nicely, 3t and t. 11 is also prime. It's gonna be an 11 and a 1. The 11 can either go with the 3 or it can go with the 1, the just t. But I wanted it to add up to 14. Negative 3t minus 11t, that's the negative 14. Then, so critical points are where, Michael?
X equals 11 with 3 is sorry, t.
Yeah. That's a thing on the test. People were like, oh, well, I found t, that's x. No. Telling you in 1 second your position is 1 is not right. Find velocity and acceleration and describe motion of the particle. Okay. Sita, how do I find acceleration?
You take the derivative of velocity. It's 12t minus 20.
And finding where that's 0 or undefined. So what does any of this mean? Like in context, what does this mean? Which one's bigger, 11 over 3 or the 1? Is velocity positive or negative at 0?
Negative. Oh, positive.
Positive. A number between 1 and 11 thirds? 2, okay. So at 2, is it positive or negative?
Negative.
And then,
Positive.
okay. Down here, acceleration.
Negative and then positive.
So what's the function, what's the particle doing? At time 0, is it moving forward to the right or backwards to the left? It's moving forward. Is it moving forward at a faster and faster pace? Is it speeding up? Or is it slowing down? Why did you shake your head?
Slowing down because the accelerator.
Okay, it's slowing down because velocity was positive, but acceleration was negative. Until 1 second, there's a brief moment that it's gonna be accelerating in the negative direction. And then it's going to, so the object turns around 1 second and starts going faster in the backwards direction, and then turns around again at 11.3 seconds, kind of, sort of. So you might need to interpret at 4 seconds what's going on. Is it moving forward? Is it moving backwards? Is it going faster or is it going slower? And we have not a lot of time. The homework. The homework has specific instructions to it, because there's a lot of subparts. I don't want you to do all the subparts, so please don't waste your time. You can choose to not follow directions, your choice. So. Some of these, doing the double derivative of some of them are just horrendous. I have done them, I don't recommend it. So the homework, which you should have started yesterday, I will leave you the rest of the time today. Technically started on the other page. But the ones that are, take more effort, and there are textbooks around the room. Just the 11, the others.
Yeah.
Yeah, okay, so not as involved. Oh, so 11 and 23. Sorry, 11 and 23, just the A, B, and E.